The modern space race between the United States and China represents a pivotal moment in human exploration, echoing the Cold War-era competition with the Soviet Union, but with far higher stakes in technology, geopolitics, and economic dominance. The content provided delves into a recent NASA hearing titled, "There's a Bad Moon on the Rise: Why Congress and NASA Must Thwart China in the Space Race," which underscores the urgency of this rivalry. Former NASA Administrator Jim Bridenstine and other experts paint a picture of China's aggressive advancements. From successful rocket tests like the Long March 10 to early lunar lander prototypes, positioning them as a formidable challenger. This narrative isn't just alarmist, it's grounded in observable progress, such as China's operational space station and plans for a lunar base by 2030. The U.S., through NASA's Artemis program, aims to return humans to the moon by the late 2020s, establishing a sustainable presence that could lead to Mars missions. However, the content highlights complexities that could delay this, prompting a deeper analysis of the program's strengths. One of the most compelling strengths of the Artemis approach lies in its foundational hardware, which Bridenstine himself praises despite his overall skepticism. The Space Launch System rocket stands out as the most powerful ever built, capable of hurling massive, though criticized for cost overruns, ballooning to over $20 billion, and delays that pushed its first launch to 2022. The SLS has now proven its mettle with the successful Artemis 1 mission in 2022, which sent an uncrewed Orion capsule around the moon. Bridenstine notes that these issues are behind us, emphasizing the rocket's readiness for crewed flights. This reliability is crucial in a program where failure isn't an option, providing a stable backbone for lunar missions. Similarly, the Orion crew capsule is hailed as a standout component. Designed for deep space travel, Orion offers advanced life support, radiation shielding, and abort systems that surpass anything from the Apollo era. Its partial reusability, key components like the crew module can be refurbished beyond hardware. Artemis's strength is its emphasis on international collaboration and commercial partnerships, which differentiates it from China's more insular approach. The program involves contributions from the European Space Agency for the service module, Japan for lunar rovers, and Canada for robotics, fostering a coalition that amplifies resources and shares risks. This model not only distributes costs, but also builds diplomatic ties, ensuring that if the U.S. leads, allies follow. The content stresses that losing this leadership could erode trust among partners who might pivot to China. Moreover, integrating private companies like SpaceX and Blue Origin introduces innovation and efficiency. SpaceX's Starship, despite its controversies, represents a paradigm shift toward fully reusable spacecraft, potentially slashing launch costs from billions to millions per mission. This commercial infusion aligns with America's entrepreneurial spirit, turning space exploration into an economic engine rather than a government-funded endeavor. Another key strength is the program's focus on sustainability over spectacle. Unlike Apollo's Flags and Footprints missions from 1969 to 1972, Artemis aims for a permanent lunar presence through the Gateway Lunar Orbital Station. As Bridenstine suggests, Gateway could serve as a hub for ongoing operations, allowing access to any lunar site at any time, with contributions from commercial and international partners. This forward-thinking strategy addresses resource utilization, such as mining lunar water ice for fuel, which could enable deeper space ventures. The content effectively argues that this approach positions the U.S. for enduring dominance, even if China lands first. By prioritizing technologies like in-situ resource utilization and advanced habitats, Artemis lays the groundwork for a multi-planetary future, where the Moon becomes a stepping stone to Mars and beyond. In essence, the strengths of Artemis lie in its robust hardware, collaborative framework, and sustainable vision, which collectively counter China's momentum. These elements not only mitigate risks, but also amplify the program's potential impact. However, as the content reveals, these positives are tempered by significant challenges, which we'll explore in subsequent parts. While the Artemis program's strengths provide a solid foundation for U.S. space ambitions, the content from the NASA hearing exposes deep-seated controversies and criticisms that threaten its timeline and effectiveness. At the heart of these debates is the program's architectural complexity, particularly its dependence on unproven technologies like orbital refueling and the integration of SpaceX's Starship as the lunar lander. Former NASA Administrator Jim Bridenstine articulates these concerns vividly, describing the sequence of events required for a successful Artemis III mission as extraordinarily intricate and fraught with risks. He outlines a multi-step process, launching a Starship as an orbital fueling depot, followed by potentially dozens of tanker Starships to refuel it, all without delays or failures. This refuel depot would then transfer propellant to a human-rated Starship, which must rendezvous with the SLS-launched Orion capsule in lunar orbit, dock, transfer crew, and descend to the surface. The astronauts would spend 7 days on the Moon, without immediate access to Orion, which orbits in a near rectilinear halo path. This setup, Bridenstine argues, introduces unprecedented uncertainties, especially since cryogenic propellant transfer in space, using liquid oxygen and methane, has never been demonstrated at scale. This reliance on orbital refueling is one of the most contentious elements, sparking debates about feasibility and innovation versus recklessness. Critics like Bridenstine highlight the historical absence of such operations, noting that while concepts have been studied for decades, no entity has executed them practically due to technical barriers. The process involves docking 2 massive starships in orbit, creating artificial gravity through thrust to settle propellants, and then transferring fuels under precise pressure differentials. Any mishap, such as boil-off, where cryogenic fuels evaporate in space, could jeopardize the mission. Elon Musk, SpaceX's CEO, counters this on X by emphasizing that docking Starship variants is simpler than routine International Space Station operations, which SpaceX performs regularly. He points to planned tests with Starship version 3 in the coming year, suggesting that private investment and rapid iteration position SpaceX to succeed where governments have faltered. However, Skeptics argue that optimism doesn't equate to proven capability, especially for a flagship NASA program funded by taxpayers. Jared Isaacman, a private astronaut and former NASA administrator nominee, adds nuance in his X response, defending refueling as a game-changer for beyond-moon applications, like Mars missions or satellite servicing. He critiques the alternative, reverting to Apollo-style landers, as short-sighted, but acknowledges the program's overall complications, including the $100 billion spent over decades with little to show. Another major controversy revolves around the decision-making that led to this architecture. Bridenstine laments what he calls the biggest decision in NASA's history, prioritizing a massive rocket, SLS, over directly procuring a dedicated moonlander. This choice shifted the burden to commercial providers like SpaceX and Blue Origin, whose landers, Starship and Blue Moon respectively, both require orbital refueling. While this public-private partnership aims to foster competition and reduce costs, it has resulted in delays. Starship's development, marked by explosive test failures in early flights, exemplifies the risks of betting on emerging tech. The content notes that the Federal Aviation Administration is approving up to 44 Starship launches annually from Launch Complex 39A, with plans for 76 more from Site 37, potentially exceeding 100 launches per year from Cape Canaveral. This scale raises environmental and operational concerns. Frequent closures for testing and launches could disrupt other space activities, strain local infrastructure, and increase noise and pollution in surrounding communities. Critics fear this creates a monopoly for SpaceX, dominating U.S. launch capabilities and sidelining competitors, which could stifle innovation long-term. Geopolitical tensions amplify these criticisms, with the hearing framing the U.S.-China race as a zero-sum game, where failure means ceding space leadership. China's milestones, such as the Long March 10 static fire and lunar lander tests, are portrayed as evidence of their relentless drive, prompting accusations that NASA underestimates the threat. Bridenstine's blunt assessment that it's highly unlikely the U.S. lands before China has ignited backlash, with some viewing it as defeatist and others as a necessary reality check. Isaacman agrees on the risk, but questions past expenditures on SLS and Orion, which face ongoing issues like suit readiness and lander delays. The absence of concrete solutions in the hearing, as noted in the content, fuels frustration. Why highlight problems without alternatives? Bridenstine's pivot to emphasizing Gateway as the high ground is controversial too, seen by hawks as conceding the surface race, and by pragmatists as strategic repositioning for sustainable dominance. These controversies underscore a broader tension in U.S. space policy, balancing bold innovation with reliable execution in a high-stakes international arena. While private sector involvement promises efficiency, it introduces variables that traditional NASA programs avoided. As the content suggests, dismissing complexity outright hinders progress, but ignoring risks courts disaster. Addressing these criticisms will be crucial for Artemis's success, setting the stage for future implications explored in the next part. The controversies and criticisms surrounding NASA's Artemis program, as illuminated in the hearing content, carry profound implications for the future of U.S. space policy, extending beyond the moon to broader geopolitical, technological, and economic arenas. If unaddressed, these challenges could result in the United States ceding ground to China, not just in lunar exploration, but in establishing norms for space governance, resource utilization, and military applications. China's ambitions, including a permanent lunar base and potential helium-3 mining for fusion energy, position space as a domain of strategic competition akin to the high seas or cyberspace. A U.S. delay or failure in Artemis could erode alliances, as international partners like ESA and JAXA might hedge bets by deepening ties with China's International Lunar Research Station initiative. Economically, leadership in space translates to trillions in potential value from asteroid mining, satellite economies, and tourism, opportunities that China is aggressively pursuing through its Belt and Road Initiative extensions into space. Technologically, the program's reliance on innovations like orbital refueling could either propel America into a new era of reusable, cost-effective space travel or expose vulnerabilities if development falters, leading to budget overruns and public disillusionment. On a positive note, the implications of succeeding with Artemis are transformative. A sustainable lunar presence via Gateway would serve as a proving ground for Mars missions, testing life support systems, radiation protection, and ISRU technologies in a real-world environment. This could accelerate human expansion into the solar system, fostering industries like space manufacturing and biotechnology. The content's emphasis on repositioning Gateway as the high ground aligns with this vision. An orbital outpost enables flexible surface access without the risks of rushed landings, allowing commercial entities to deploy habitats or rovers independently. Jared Isaacman's perspective reinforces this, arguing that investing in complex technologies like refueling isn't just for the moon, but for extending America's ability to explore, discover, and defend in space. If orbital refueling succeeds, it could democratize deep space access, enabling frequent missions at fractions of current costs. SpaceX estimates Starship could reduce per-launch expenses to under $10 million. This would spur a space economy boom, creating jobs in engineering, data analysis, and logistics while positioning the U.S. as the hub for global space ventures. However, realizing these implications requires proactive policy adjustments. First, Congress and NASA must diversify the Artemis architecture to mitigate risks from over-reliance on Starship. Recommendations include accelerating Blue Origin's Blue Moon lander as a backup, which, while also requiring refueling for later variants, offers a more conventional design with proven elements from the New Glenn rocket. Allocating additional funding, perhaps $5 to $10 billion over the next 5 years, could expedite parallel development, ensuring redundancy. This approach echoes lessons from the Commercial Crew Program, where Boeing and SpaceX competed, ultimately delivering resilient options despite delays. Second, address regulatory hurdles. Streamline FAA approvals for high-cadence launches while incorporating environmental impact assessments to balance innovation with community concerns. Policies could mandate noise mitigation technologies or launch windows that minimize disruptions at Cape Canaveral, preventing bottlenecks that could halt progress. Third, enhance international collaboration to counter China's influence. The U.S. should expand the Artemis Accords, non-binding principles for responsible space behavior, to include more nations, emphasizing transparency and shared benefits. This could involve joint funding for gateway modules or technology exchanges, solidifying a democratic alliance in space. Domestically, invest in workforce development, programs to train engineers in cryogenic systems, and AI-driven mission planning would build capacity for complex operations. Bridenstine's realism about not beating China to the surface suggests a narrative shift. Frame Artemis as a marathon for sustainability, not a sprint for prestige. Public communication campaigns could highlight milestones like Starship tests to maintain support, countering pessimism. Finally, integrate private sector incentives more deeply. Tax breaks for R&D in refueling tech or grants for small businesses developing lunar tools could accelerate timelines. Isaacman's call to rethink past decisions implies a need for agile contracting. Move away from cost-plus models that rewarded delays in SLS toward fixed-price agreements that incentivize efficiency. Monitoring China's progress through intelligence sharing with allies will inform adaptive strategies, ensuring the U.S. remains responsive. In conclusion, the future of U.S. space policy hinges on embracing complexity while hedging risks, turning potential setbacks into stepping stones for dominance. By implementing these recommendations, America can secure not just a return to the moon, but a lasting legacy in the stars, outpacing rivals through innovation and partnership. The hearing's insights serve as a wake-up call. Space is no longer a frontier of dreams, but a battleground of realities.